Hello dear students, welcome to Pen and Paper Chemistry on YouTube. So, are you all ready with your pen and notebook? Because we are going to talk about the preparation and properties of aldehydes and ketones in this video and the videos further on from here. In the previous video in the series, I've already shared with you this flow chart wherein we listed only the preparation of aldehydes and ketones. Now, why are we doing that? Aldehydes and ketones are a part of compounds which are known as the carbonyl compounds. What do we mean by carbonyl compounds? Compounds having the functional group C double bond O. If you see in the case of aldehydes, you must be wondering what is these two lines that I have drawn. These are the two free valencies. So when you talk about aldehydes, one of the free valency is occupied by hydrogen. The other can be any other alkyl group or it can be hydrogen. So I can have H C double bond OH. That's the first compound of the series called as methanol or commonly known as formaldehyde. Now, those who are not very comfortable with the concept of naming, then there is a separate set of videos dealing with the nomenclature of compounds. Same way, if I have let me put it like this. So I have H C double bond O, again one hydrogen, the second let's suppose is CH3. Now this compound, because I have two carbon atoms over here, this would be named as ethanol or commonly known as acetaldehyde, right? Same way the series continues, so we can have, instead of CH3 we could have C2H5 and so on and so forth. So that is why I said the second group can be an alkyl or it can be hydrogen. What about ketones? There, in the case of ketones, both the free valencies are attached to a carbon. So I will have, let's say, I will take the example of the first ketone in the series, so CH3 and CH3. Total 3 carbon atoms, so 1, 2 and 3. Hence the word root is prop, saturated, so ane, and then we have a ketone, so one. Propanone is the IUPAC name of this compound, or commonly also known as acetone, right? I hope you are all writing this down. It will come in really handy when you sit down to revise for your exams. Anything written down in your own handwriting is much more relatable compared to printed notes. So please go ahead, pause the video, write this down. Now, I am going to make use of the flow chart that I had given you earlier. Write this flow chart. In this flow chart, if you see, there is preparation only written over here. There are no properties. I'm taking up the preparation of aldehydes and ketones together because they are quite similar. So you will be able to relate to them more easily. There are 6 different methods of preparation, so half of them listed on the left and half of them listed on the right. And how do you know it is preparation? If you see, all of these arrows are pointing towards aldehydes and ketones. So you're preparing or converting alkenes to aldehydes and ketones, alkynes to aldehydes and ketones, alcohols to aldehydes and ketones. Also, one correction over here. In the previous video where I have shared only the flow chart, by mistake, sorry, there were 2 E over there, yeah. So I have corrected myself over there. Excuse me for that. So are we ready to write the reactions? But make sure that you have your flowchart on the side kept with you for ready reference. So as you can see, I have also placed my flowchart on the right hand side top corner for ready reference. But would you get to keep this flowchart for your exams? No, you won't. But then by that time you'll be very confident in the topic and this flowchart would be embedded in your mind for quick reference. So when we talk about the preparation of aldehydes, the first one we are talking about is the preparation of aldehydes and ketones from alkenes by the method which is known as ozonolysis. What is ozonolysis? Ozonolysis is made up of two parts, that is addition of ozone followed by hydrolysis, and hydrolysis means H2O. How do we do that? The addition of ozone usually takes place in the presence of organic solvents like dichloromethane or methanol. Hydrolysis is done with the help of zinc dust and water, or zinc dust and ethanoic acid, or dimethyl sulfoxide. By the way, this reaction has been dealt in greater detail under the topic of alkenes. So let's get started. Now if you can see, I've just written a simple compound, a generic structure for an alkene. If you are uncomfortable writing the free valencies like this, you can also mark it like that, meaning to say there can be hydrogen or there can be alkyl groups. So let's first step add ozone in the presence of organic solvent like CH2Cl2 or methanol. Don't forget the solvent for the reaction. What is going to happen over here? The double bond addition will take place across the double bond. So let's get started. So here and here. So I have oxygen, oxygen, oxygen. So if you can see here, 1, 2, 3 bonds, 1, 2, 3 bonds. There's one more bond to go, and here we have another ozone molecule connecting. Now next step is hydrolysis. So let me write only one of the reagents. Please go ahead and write the others. Hydrolysis with zinc and water. So here it will break down. Here it will break down, and what will the water do? It will combine with the oxygen. By the way, this is not the mechanism exactly, but I'm trying to make things easy for you. So we have over here C double bond O plus again C double bond O. Where does the C double bond O come from? You see over here, there's single bond C, and this single bond will now turn to double bond because our bond here has broken and it will shift to form a double bond. This will be shifting to form a double bond. So I have two carbonyl molecules and of course hydrogen peroxide, right? Now why don't you try writing this reaction? So I have CH2 double bond CH2 listed for you over here. Go ahead, write the first step, addition of oxygen. Don't forget the solvents here, write it. Let's write it in an expanded form now. H, O, C, O. Sometimes we make the mistake of putting a single bond over here. Okay, if I put a single bond, you see how many bonds is the carbon forming now. Look at the number of the bonds with carbon. Yes, so it's 1, 2, 3, 4, 5. Is carbon able to form 5 bonds? No. So you can actually correct yourself there. And next step is hydrolysis. Zinc plus water, zinc plus acetic acid, or DMSO, right? Again, shifting of the bonds. So here double bond, here double bond, and I can also show the breaking like this. Beautiful diagrams, colorful, right? So what compound do I form here? Yes, I am getting 2 molecules of methanol here, which is an aldehyde, formaldehyde, right? So I can straight away write 2 molecules of this and hydrogen peroxide. Correct? Okay, now pause the video, try the next 2 yourself. Go ahead. It will help to boost your confidence on the topic as well as in organic chemistry. Believe me, it really helps. By the way, if you have written it simply like this, that's also good enough. Okay, so I am going to write over here CH3. Tally the products over here. CH3CHO plus HCHO plus H2O2. Now, if you see over here, what we are doing is we are just breaking down this bond, putting an O here and putting an O here. Yes? So, that's how I got here a CH3CHO, one aldehyde, and of course CH2O is actually HCHO, right? So, I've got a mixture of 2 aldehydes. Oh my God, I actually want to make things easy for myself. Do I want this mixture? Because aldehydes means their boiling points will be quite close to each other. It will be difficult to separate. So let me try and do something here. Instead of taking CH2 here, why not take another of this group only, CH3.CH? Now what do you think would be the product formed? Okay, just break it down. Yes, I just gave you the trick. O here. Yes, so the only modifications I'm going to make here is CH3 and here becomes CH3CHO. Oh, that's interesting. I am getting a single aldehyde. So 2 molecules of CH3CHO, which is called as ethanol or acetaldehyde. What is the difference between this one and the previous one? Okay, CH double bond CH2, right? This is the simplest alkene that you have. So this is an alkene in which none of the hydrogen atoms have been substituted. So this alkene is an unsubstituted alkene. Next step, I replace one of the hydrogens by an alkyl group. So I put here CH and a CH3 here, double bond CH2. So what I've got is I've got a substituted alkene. But what kind of substituted? It is mono-substituted alkene. And what was the problem with that? I was getting a mixture of aldehydes or mixture of carbonyl compounds, right? Again, which are difficult to separate. So what did I do here? I removed one of the hydrogen and placed a similar alkyl group at the bottom. And what did I get? I got a substituted alkene, right? And that substitution is double substitution, so di-substituted, and if you see, it is symmetrical. It is symmetrical means if I draw a line through it, both the upper and the lower parts are the same. Hence, we can write it as symmetrical di-substituted alkene is going to give us, what do we get? No, we don't get a mixture of aldehydes. We get aldehydes other than methanol, right? Okay. Now, how about replacing the second hydrogen atom at each of these groups with another alkyl group? So, what do I have over here? CH3 and a CH3. That means instead of a di substituted, now how many substitutions? It's tetra substituted. All 4 hydrogen atoms have been replaced, but it is again symmetrical. You see, the 2 parts are mirror images of each other. So what will I get here? Remember the trick. Just break it down, attach an oxygen, just break it down and put an O. So put an O, put an O. So what do you get? Yes, you get 2 molecules of ketone. Right? Now look at the flow chart. What did we write over here? Alkenes on ozonolysis, that means treatment with ozone followed by hydrolysis, give us aldehydes and ketones. Ethene gives us methanol. Symmetrical di-substituted alkene gives you any other aldehyde, whereas a symmetrical tetra-substituted alkene gives you a ketone, right? And this is what it is. A symmetrical tetra-substituted alkene is giving you a ketone. So why don't you do one thing? Why don't you try writing the reaction steps for ozonolysis of this compound? Go ahead. So I'll give you the compound here, CH3, C, CH3, double bond, C, CH3. Yes, you can give its IUPAC name if you want to add to the fun. And step 2, and what do you get? Isn't it easy if you know the steps? So this is just one preparation. Don't worry, the first time it will take a little longer to understand, but further on, once you get a hang of it, you won't have to keep repeating and you won't have to keep flipping through the pages. Our next preparation for aldehydes and ketones is from alkynes. Why don't you give it a try? I have already given you a hint that it is done by hydration. So what you are doing is you are simply adding water across a triple bond, HOH. Don't forget the Markovnikov rule. And before I give you the video for the preparation from alkynes, why don't you give it a try and keep it ready so that you can check it when we do it in the next video. Stay tuned, stay connected, and stay always happy. See you in the next one.